Good morning. Before I say anything else, remember everything you just saw because you need to know all that plus everything else. So I'm not going to go into the details of it. My name is Norbert Jurkiewicz. I work with the Carlyle Group. I'll go into the details in a minute on that. But I originally agreed to this talk, and I was going to talk about using Amazon Web Service to do your application builds. I very quickly realized it's too complex of a topic. You really can't discuss any of it unless you want to spend a day on each subtopic and then a couple of days on each one of that if you're really going to understand it. So I'm going to do a high-level overview of my daily workflow, which includes building the application or letting some of our other colleagues build it. So let's call it semi-AWS automated application builds. So I'm a developer at the Carlyle Group. I've been doing it for a long time. Sometimes I dream about it. It's kind of sad. The application is mostly APL, but it also contains .NET, C#, C++ libraries. We've now started incorporating HTML5, CSS. It really is a great thing. AWS, we've been using it for 10 years now, probably been longer internally for testing, and externally hosting some activation services which incorporate APL, C#, and our website now for our help. So very comfortable with it, and I also know the dangers of it, so I will comment on that. The main product which I work on is a Windows application. It's a collateral analysis system. It does what half of you do, stores data in columns, makes some numbers, produces some reports. Nothing surprising there. I want to go over the architecture of it because there's a lot of moving parts, and that makes it difficult to build. The interpreter and the things that we distribute is Dyalog 14.1. We still use it, and it's in production. It's been running very well. We've now started using 18.2, and our actual customers are being delivered CAS in 18.2. Unicode 32 and 64-bit. It's actually shocking. We still have people requesting 32-bit installers as much as we don't want to provide them. .NET and HTML, CSS, JavaScript. You're going to hear me talk a lot about that. For building the actual application, we use Dyalog 18.0. I know it's we don't use it for production or anything, but I put this together a couple of years ago when it just came out, and it works. GitHub Actions, which you just saw in action. Node, that's a new addition now. I wrote a help system to compile our Markdown and JSON into searchable, indexable, static web page in APL. And I very quickly realized I could just rewrite the whole thing in JavaScript very quickly and let GitHub host it without a Docker container. So that was pretty much the only reason I did that. It was seamless, easy, and there was a million libraries to do, so I didn't have to rewrite them. AWS environment, self-explanatory, and the Wix toolset. So we distribute MSIs, distributables. We need to build it, so we've been using Wix about a decade on this. It works really well. We have a couple internal APL libraries that actually construct the Wix XML for you from a couple of APL functions. Just a couple icons. There's more to it. We distribute a whole bunch of third-party utilities that we license. Some of them are OCX controls to display PDF, which now we're moving to the HTML renderer. But the Dyalog 14.1 distribution obviously does not have that, so we still need to distribute a 32 and a 64-bit PDF viewer. There's printer drivers that we distribute for printing PDF, .NET libraries, JavaScript, and executables. We actually run a couple command line utilities from the application to convert certain reports to XML, I'm sorry, not XML, Excel and PDF. Open source stuff, JavaScript libraries, whatever Dyalog provides us via CEF, and APL packages that we've put together in open source. They're available for anybody to use, such as Excel to APL. If you want to read an Excel file without any COM interaction, that's actually available to download and use. To release the application, we have recently put together an online help, which uses all Markdown source that's kept in our repository along with the source code, so everything is versioned same time. If you change your source code per release out, your help is versioned with it. GitHub Actions are great because if you change your branch or you check out a different tag, it'll rebuild your application along with your help, and everything is synchronized. Windows Desktop MSIs, everybody's familiar with these things. We're not getting rid of them in our application anytime soon, but if you're starting something new, don't do it, just go online. Code signing, which is I never heard anybody mention it yet. When you're delivering your code and you don't want any warnings to pop up on your application, you need to have a certificate that signs the executable or particular files that says, hey, these people actually produced it, you can verify it. If you don't do that, you'll get this pop-up in your browser that says, are you sure you want to download this? Is it safe? Are you really, really sure? And it's distrusting by customers, so you have to go through this whole process of signing that. Source code management, text only. We've been using text source codes for about 6 years, and we've been not using our workspace for over a decade. We store all our source code in Git. GitHub is where we actually store it online and does our management. And we have a package called Data, which you've heard Morten mention before. Data allows us to read source code in and out from kind of like Link. Link is great, but we've just been using this for so long, we're not going to switch until we have to. Data also does our packaging and our versioning. So when I say build application today, it's going to bump up the version number, it's going to put together a release, upload it to GitHub, and then it knows how to fetch other dependencies from GitHub that are either public or private and follow the convention we use. So project management, Data is built on top of ACRE. You've heard this before. So ACRE is Link, basically, and we use it internally, but it seems like we're probably going to move it internally to Link at some point soon. Whatever you do, use one of these things. Really, you should not be using a workspace anymore. Release building. Why do we automate? Well, you don't want to build your application on your desktop. Who knows what this has been through on my travels? I can't build something and deliver it to a customer and feel good about it. So you want a clean and trusted environment every time, and you want to be able to repeat that. So that's where consistency comes from. Consistent development environment. We have a couple PowerShell scripts that will actually install everything for us that we need to develop our application. That's going to go and grab APL, grab any other dependencies that we need for development, and install it for me. So it'll do it on the build environment and the same thing on the local environment. So if I got a new laptop last week, I run a PowerShell script, I come back 3 minutes later, everything's installed for me. So it makes it easy. Very important part, anyone can build the application. So we are a shop of 5 people, 3 APL developers, and if I make a change, they can't be relying on me to build it for testing and acceptance. So we have a couple other colleagues that can log into either GitHub, or they can download the repository from GitHub if they have access to it and double-click a PowerShell script, and it'll build the whole thing for them. They don't need to know anything else. So even if somebody else goes in and updates a help page, which is very simple, it's a markdown page, they can rebuild the application for testing just by double-clicking something. It's scalable. This is important, and it's becoming more important for us than I imagined, because it turns out you can't just deliver one executable anymore. We wanted, and for the longest time we strived to have one installer for 32, one for 64-bit, and that was great. But now we're getting demand from our clients to have customized releases, be it nothing but a logo or some specific functionality that only they want. So it takes anywhere from 3 to 6 minutes to build a installer. An installer is 170 megabytes, so that has to be built, uploaded, checked, and now multiply that 50, 60, 100 times, 32 or 64 bits, so a single machine can take all day to do it. When I do this on the cloud or AWS, it takes about 10 minutes to put a release out, from building the whole infrastructure to downloading the code, installing APL, compiling it to an MSI, uploading it, destroying it, and it's quite a long time. On my laptop, it'll probably take 25 to 30 minutes, so that's not doable. If I'm deploying 25 installers, I could either have one very big machine run serially, or I could have 25 machines, run them sequentially. Cost is kind of the same because you're paying for compute time. So something to think about. And so I'm going to go over my workflow. First, we code, test, push changes, some GitHub action, magic happens where it recompiles our help. Then the application gets built. Then if it's accepted after testing, we sign the application and release it. So I'm just going to go over my day-to-day operations here. So in the morning, I get into the office, also known as my spare bedroom. And I start Dyalog, and I do a data.open project, and I say OpenCast 7, and that loads the workspace. Well, I'm sorry, it builds the workspace from the text source code. It loads any dependencies. So if Paul, the guy I work for, he changes something in FlipDB or Abacus, and as long as my project knows that there's a new version, it'll automatically download it for me, and it tells me, hey, you've got a new version. It's from a cache, or it's downloaded from GitHub. It's not on your local machine, so I could see what's going on. And this is for development. For building, everything is static. You have to specify the exact version of every dependency. We do not allow automatic versioning or upgrades. There's no, version 2.1 star, which means all of these should work. It should, but are you going to trust that? So that's that, and then you could see in here I did a little work. I made a function called new function under user settings, and I wrote some testing. Testing's great. We've been doing this for a very long time. Same framework, basically. You have a function that returns a 1 or a 0, either passes or not, but your tests are important. That created some text files, and I just can show it here. I can do some magic. So that's my coding. Very exciting stuff. Then we run some tests. In this case, I abbreviated. I didn't run the whole suite, which I probably should have. But I loaded a library. There's test library, run test, which is a test runner. And in this case, it ran everything and told me quite often, I don't want to keep on working in an environment I tested on because there's specific things that are getting set to make that possible, especially testing Windows GUI, which is super crazy. It's hard, and that's why I can't run it in a Docker. So that happens. After that, and this could have been done before the test, we push our changes to GitHub. So I do a commit locally and then push it to GitHub, and you could see that happen. You could do this any number of ways. So if you're not using source code management yet, you could use shell, you could use your command, you could use your user commands from APL using data or another project, or you could use GitHub Desktop, Git Kraken. There's a million tools. I'm sure you could probably write curl code if you really wanted to. So this is the cool part. So you just went over GitHub Actions, and we're relying on them in two ways. One of them is to generate our help. When I push a change or anybody else on the team to the GitHub repository, GitHub knows something changed in a specific directory. It runs a version of Node, it downloads some JavaScript, and it downloads all the source code, compiles into HTML, compiles a searchable index along with any other resources it may need to download to create a static package website that gets pushed to a GitHub page, so it's hosted immediately for testing, not distribution. And then also the same thing gets pulled back into my local session, so now I have a updated version of our help as a website, which gets hosted either online or with an HTML render and then newer releases. So your help is built by Node. And I'm saying this uses a GitHub action because it's easy. It does it on the server. It's consistent. I could do the same thing locally if I'm not online. There's a little command that says, run local as long as I have Node installed. And the reason I use Node for this because there's a couple packages for Git flavor Markdown conversion, which really like the way the Markdown gets converted in GitHub. I'm sure we could have written it, but why? There's a million libraries. They're tested. Don't make your life too hard. Okay, so this is with actual cool stuff. Once all that's created, and that happens in a matter of minutes, especially the constructing of the help. We have a couple PowerShell scripts that are part of the actual repository, so anybody that has access to the repository in the company can go ahead and just double-click them. And these do a lot of things. They create all of the AWS infrastructure. So I'm not sure how familiar everybody is with it, but for the main things we use is an IAM role, an EC2 instance, S3 objects, and secrets manager. So IAM is a virtual user account that gets generated on the fly with only the permissions to access the resources it needs. So we tell Amazon generate user 123, give it access to create one virtual machine of this size in this region for this length of time. It does that. It also starts it. Then we generate some S3 buckets, which is storage. We need to be able to push our build somewhere. And then secrets manager. Never ever pass API keys, passwords, usernames in your source code. Don't do it. The last conference, I, by mistake, submitted some API keys to our AWS account into the GitHub directory, and by the time I left, there was a $100,000 bill on my Amex card. It took a long time to clean up. Do not push your keys to the API, especially your master keys. They did take care of it, but it was up to me to find every single instance of the stolen of anything that was set up, because they don't know what's real, what's not, and it had to be justified. It was a lot of sweat, a lot of unslept nights. So the secrets manager is this magic that AWS has, which basically lets you put in a username and password, and any resource that is allocated to the virtual user that has access to that secret manager and the S3, the virtual machine, can automatically query data out of that secrets manager. So as long as you store it there, you could just get it inside your virtual machines, your Docker containers. You don't have to pass it anywhere. It just works, and it's the right way of doing the things. So right now we're assuming the PowerShell created the infrastructure, so now I have a virtual machine running somewhere, and it installed just enough things I need. So now I need credentials for GitHub. So PowerShell went to the secret manager via curl call, and then downloaded some credentials for our master repository for the main application because it's private, and it created a file. Where is this? Okay. Then it goes down, once it has those keys, it goes and downloads the master repository. This is all happening inside the virtual machine automatically. I haven't actually done anything yet. But this is equivalent to how I would do it if I set up a new machine. We store our Dyalog in S3 buckets. So we have a version of Dyalog that we use for distributing and generating the builds inside a private repository or an S3 bucket. So the PowerShell script will go and download those items. It'll install it. It'll configure the session by setting registry entries if it needs. And it'll also create a little shortcut on the desktop for me in case I want to do it manually. It'll install Git, AWS, if there's any specific items we need that are not part of the standard distribution. It goes and installs Node. Any user commands automatically get installed because everything I'm doing on my desktop gets replicated automatically on the virtual environment. And you can see I can actually start this whole process either by double-clicking a shortcut I have, which is not really clear here, or in the session by running a user command. It's all tied together in one place. All right. After all that is installed, the PowerShell starts Dyalog, and it loads it starts Dyalog, and it runs a user command that says open project with a parameter that says build, so it knows how to run a specific virtual quad LX for building the application. And at that point, the application starts, and again, Acre data loads up the workspace, and it loads up all the dependencies. It went and downloaded them from GitHub, same as I do locally, but I download the specific versions for the release, because now everything is very versioned, right down to the minor detail. So I was just talking about that. So the APL session goes and compiles the MSI using Wix toolset, and then it makes sure that it's a valid release or installer. It uploads it to a couple places for validation. We upload to box.com, S3, and Dropbox. The beauty of uploading to S3 from another Amazon resource is that it's instant. They have sub-millisecond access to S3 objects, so even if you're relying on a lot of resources, it's very, very quick. Regions, especially in the same region, also doesn't cost you anything. If I create a resource in Amazon, a EC2 machine, and I upload it to S3, it doesn't cost me anything to transfer the data back and forth. If I upload it to S3 bucket for my local machine, I'm paying for the I/O to push up and down. So depending on how much data you're using, you have to consider that. This is going to become more critical now that we're building many installers, because I could be pushing 10, 15 gigabytes at a time with 30 installers to S3. I want it to be fast, and I want it to be cheap. The other beauty of this is it doesn't use any resources on my machine, so I could launch this off an airplane Wi-Fi if I really wanted to, and it all happens somewhere else, and it'll just do the upload. So you become much more efficient. Plus, I don't like my machine just grinding away for 2 hours. I mean, it's a good excuse to go for a walk or something, but I could just go for a walk and pretend it's doing something. All right, so when all that is done and it's successful, the system generates an email that sends an email to everybody in the company that says, hey, Norbert, Chala, Paul, whatever, they put out a release, its version. Here's a link to direct downloads of it. Have at it, start testing. This is for user testing. So make sure actually when you click this, it does that, or the actual manual testing. After all that is done, the dado function that does all the building has a quad off, and it also sends a shutdown command to the Windows machine. And when that happens, the virtual machine shuts down, and then the PowerShell script that started the whole thing resumes because it's in a suspended state, and it's going to delete all the user roles, any unnecessary S3 objects, any VPCs, load balancers. What else is there? Security policies. That's an important thing because you need to be actually log on to these things. So you're creating certificates, security policies, you want to take them down. The whole time when this is happening, I have not touched this machine once, nor did I care about a password or anything. It all happens automatically through PowerShell and the AWS resources. Important thing, if your build fails, you don't want to have a suspended AWS EC2 machine running for a month that's costing you $10 an hour. Put a timeout in your startup scripts. So the initial script, when it creates the machine, also puts a 1 hour timeout. Regardless of if my build is done or not, 1 hour after, it's just going to kill the whole infrastructure and take it down and send me an email that this failed. That's important, especially if you start 20 or 30 of these and you messed up your build process along the way in development. All this that I described that happens manually, automatically can also happen manually. The PowerShell script that runs also has a brother version of it that says do it in manual mode. It creates all these resources on AWS, and then 5 minutes later on my desktop, I get a virtual desktop logged in with all my resources installed. So I have Dyalog, all the versions I need. I have my run command, which is the actual function that starts the build, and I could just double click on it and watch the whole build process happen remotely. And then at that point, I could just shut the machine down, and then I can look in the AWS dashboard, and it says it's terminated, so I know it happened. If you're looking at your dashboards and you create and destroy resources, sometimes it takes 1 to 5 hours for them to actually go away. So just make sure it says terminated, not just shut down and in a suspended state. Let's assume all that worked, and my colleagues went and downloaded the installer, and they checked it, it does what it wants. We're going to say, okay, we're going to put this out on the website. We need to sign these releases. There's something called an extended validation certificate now, which basically says you went through a process of auditing your company, and they know who you are, they checked your tax records, they checked that you actually are who you are. Per Microsoft, that gives you the ability to have a green check mark next to your application when you install it, instead of warnings asking you, are you sure you want to install this 3 times? Extended validation certificates come on YubiKeys or USB disks, which is a royal pain because this used to be automated. A regular certificate, you could automate your code signing as part of your process, and you wouldn't have to do this, but now I literally have a key, a USB drive, and a safe, and so is one of my other colleagues, and we want to actually put a release out. You have to plug this in, and there's a little bit of APL code that says go, download everything, and run this, basically run this command line from the terminal on every single file, and then you have to put in a PIN for that YubiKey. There are ways, I guess, of automating this. It's just expensive because it's a virtual signature, so you have to upload your MSI or whatever code you're signing up to, say SSL.com's website, and then they have a virtual way of doing it. It just, it costs money. I mean, it's like you're talking a couple $100 a month, even if you don't use it. So if you're infrequently building items, this is probably the way to go. So now our code is signed. If you look at the installer here, it says, we are the Carlyle Group, the signature is valid. I'm not gonna show you the full details certificate, but it's out there. Then we just upload. Either our website will accept FTP uploads or just log into the back end, and the MSIs get uploaded. If I'm putting up 30 MSIs, it's going to happen with your FTP. I'm not doing it by hand. But if we do run a one-off for another product, we'll just drag and drop it to the website and make sure that the release notes are updated. I forgot to mention this. Data, which I say a lot, does our builds, also compiles the release notes, either from your commit messages or you have a custom routine that can go ahead and compile specific resources and release notes if you want. So that is my day. And when everything works, it's great. And it's been working for about 2.5 years, because I put this together during the last user meeting. When 18.0 came out, it gave us the ability to use standard in and out very easily, or much better than before. And Paul Mansour ran with it and created this ability to create packages and builds using that mechanism. So one of the things is you always build from a clean workspace. So we have APL, driving APL, loading code, saving workspaces. Oh, I should say that. The only time we ever use a workspace is to distribute the application. We don't use a workspace for anything else, and I'm guessing if we get our way, we won't even be distributing a workspace in the next year or two. We'll just be sending out the source code and putting it together with a quad fix on the fly. Yeah, so I didn't go into any of the nitty-gritty details because, like I said, I could spend hours on each one of them. But that's the 10,000-foot overview, and obviously everybody else seems to be doing close to the same workflow at this point, which is great.